clear that. We don't want that. Oh, just why is there a way to just make that complete? You guys know how to make the Zoom thing just go away? Can I just make it go bye-bye? So there's like a, never mind. Yeah. Okay. Well, let's get to this. You have a homework assignment. It's due tonight, and I think my plan was that you'd have plenty of time to work on it in class. So it's not posted yet. I didn't much care for it last time when I was trying to do notes, and you guys were trying to do the homework assignment at the same time. So it reminded me that I need to stall the upload of the assignments until you actually listen to what you're supposed to hear. So today is 216. 21622, and this will be our second go round with solving log equations. You'll notice in Delta Math today that your assignment is called solving log equations number 2, and then tomorrow night, you guessed it, they'll be solving log equations number 3. So there's lots of different variations of logarithm equations. We don't want to give them to you all in one day and go like, boom, here you go, suckers. So anyways, that's what we're doing, is more solving log equations. Oh. Yeah, you guys figure out how to make that little thing go away. Your teacher is solid. You guys are all tech savvy and stuff. So anyhow, I have 8 examples. I have I very specifically broke this into part 1 and part 2. Neither part's going to give you much grief. As I get going through this, I'll explain to you what's going to be the difference between what we learned today and what we learned tomorrow. But for our first example, we're going to do log base 6 of 9x minus log base 6. And I'm only going to write it in parentheses like this because that's how you're going to see it in the program today. So I just want you to be familiar. If it were me on a test, I will not put log base 6 of 4. Like I wouldn't put the 4 in parentheses. I might put the 9x in parentheses just to remind you that the 9 and the x are all part of the argument of the log. But with the 4, they're certainly not necessary. I just want you to not be caught off guard when you see them. They serve no purpose. I'm sure it's just a computer programming sort of thing. So we're going to have to work backwards here today. So what you're used to is expansions. You guys showed me on your quiz, for the most part, that you're really, really good at expanding. Now we have to do the backwards of it, and we're going to work with condensing. So condensing is the opposite, obviously, of expanding. And I'm going to take the 2 logarithms on the left side of the equal sign, these 2, and I'm going to condense them back into a single logarithm. Would anyone like to take a guess as to what that might be? Good try, but no. Anyone else? There's absolutely no math to do here. It's just the backwards of property 2 for the record. And I know it's property 2 and not property 1 because property 1 would have a plus sign in between the logs. Property 2, remember, is the one that breaks into 2 logs with a minus. You want to take another shot there, LJ? Now we're talking. So for the first time ever, we're going to do a condensing. We're going to take 2 logarithms and we're going to condense them back in to a single logarithm like this. And it won't take you long, and by that I mean like no more than 10 seconds, to look at that and agree that that is just the dead backwards of an expansion. If I gave you the second line and asked you to expand it, at this point, you wouldn't even hesitate to know that it's log of the top minus log of the bottom. So we're just taking that understanding and we're doing it dead backwards. We okay so far? So good? And now we're going to embrace the water cycle diagram. If you haven't gotten on board with that yet, a lot of things to say about that, but I'll just keep it like this. You should get on board with that because it's just the heart and soul of everything that we do. Converting things from logarithmic into exponential is huge, huge, huge. And so if I embrace the little blue water cycle diagram, I'll draw it for you. I won't keep drawing it, but just this one time for our notes so we can say we did. This 2 to this equals this. And we only can get away with this now because we've written the equation as a single log equals a single thing. I couldn't have done this in step 1 because I didn't have it condensed into a single log. That's why we have to condense. And now that I've done this, what is 6 to the power of 2? So I have 36 equals 9x over 4. And it happens pretty quickly. You see this often in my class that things go from algebra 2 problems to 7th grade problems, and it happens like that. You do one little step and you look at it and you realize, well, I've been solving those since I was like 12 or 13. Eh? So to solve this now, forget everything about logs, forget everything about exponents. What would you instinctively do first to solve this equation? Yeah, and that's just something you probably don't even need me to say that. You just look at it and your heart and your brain tell you, I know I need to multiply by 4. It's just what my gut tells me. If I'm going to get x by itself, that 4's got to go. So multiplying by 4 is a great move. And then on the left-hand side, we get 120 plus 24 is 144 is equivalent to 9x. And then, of course, I hate to insult your intelligence with this, but what would we do from here? We would divide both sides by 9. Again, I'm just showing lots of work here since it's our first go around, and we're going to get x equals 144 divided by 9, 16 indeed. Okay. Any questions about that? As we go forward, I don't think it's an issue today, but tomorrow we're going to be doing this exact same thing, but with quadratics. It gets a little harder tomorrow. We'll have to worry about going back and checking our answers, plugging them back in and making sure bad things don't happen. But I think I'll cross that bridge tomorrow when we get there. So for today, we can just rest assured we're good to go. All right. So let's move on to example 2. It's going to be similar. These next 3 examples are all going to be quite similar. Can I scroll yet? Everybody okay? The next 3 are going to be quite similar to what you just did. So our next example is going to be log base 7 of 2x plus log base 7 of 2. And again, I'm only parenthesizing because I don't want you to wonder why they're there later. Which property are we going to do in reverse? Property 1, and we know that because, look at there, woohoo, there's a plus sign in between the logs. And we know that for it to have expanded into plus, it would have originally had to be what? What expands into plus? Multiplication does, right. So I'm going to condense the left side into a single logarithm of the base of 7. And what will the argument of that single logarithm be? Yes, and I'm going to go ahead and write 4x. Good job, Carter. It is indeed the arguments of the individual logs having been multiplied together. Any questions about that? Equals 5. And then from here, it's time to do the water cycle diagram. This calculator or your DMAC power table is going to be much appreciated here. Is anyone ahead of the game? I know some stuff. I don't know 7 to the 5th. I do now. It's 16,807 is equal to 4x. We good? And then, of course, your inner 7th grader kicks in and tells you, hey, pick me, divide by 4, divide by 4. And when we divide both sides by 4, I don't think you need a math degree to figure out that by definition, 16,807 cannot be divided by 4. Why? Yeah, no odd number in the world can be divided by 4, right? The multiples of 4 are 4, 8, 12, 16. It's by definition, you can't. So what we would like here is for you, just once you accept the fact that it ain't gonna work, you probably know what I'm gonna say, just leave it as a fraction. So as uncomfortable as that might feel, the answer is 16,807 over 4. It's like 4,201.75 or something. No one's interested, okay? So just leave them as fractions when that's what they're meant to be. All right, we'll go a little quicker on the next ones. log base 2 of 5x minus log base 2 of 2 is equal to 3. What's that going to say? Log base 2 of 5x over 2 is equivalent to 3. And then convert it. What's it going to say post conversion? No roots here, brother. And if you don't mind, I'm just going to skip it. Instead of writing 2 cubed, I'm just going to write 8 because that's what 2 cubed is. Save a little step there. Thank you, Carter. So 8 equals. Yeah, and actually, I hadn't even thought about that, but let's solve this problem again in just a second. I did not see that question coming, and I absolutely love it. You guys always catch me off guard, and I love that about you. So let's finish this off, and let's just verify that, hey, we got the same thing. Great question. So what would we do first from here? Let's just press on, assuming we didn't. Yeah, multiply by 2, and then that's going to lead us to 16 equals 5x, and then we're going to divide both sides by 5 and get x equals 16 over 5. I assume we're good with that, right? I want to go back. Great. If that's not the best question I get all day, I'll be massively surprised. Let's go back. If you didn't catch it, I didn't. I wasn't even thinking about it. Let's go back and look at what Jasper just brought up. I'll re-ask his question for him just because I'm louder. Jasper noticed that this log base 2 of 2 equals 1. Good catch. Great catch. So actually, I think if you want to do it this way, I don't know if it winds up saving you any time, but you could do log base 2 of 5x minus 1 equals 3. You agree? It's not a huge time saver, but it's still really cool. And then to solve this, obviously, we'd want to add 1. The water cycle diagram does not work if you don't have a single logarithm equal to something. It just doesn't work in pieces. It's not how this doesn't work. But if I add 1 to both sides, then I get log base 2 of 5x equals 3 plus 1 is 4. Great catch. Again, doesn't save time, but super fun. So if I take 2 and I raise it to the 4th, bless you, I get 16 equals 5x. And of course, we get the same answer. So. Neato. Good. You guys have any questions about those? I feel like I can probably skip the 4th example. I don't imagine that that's vexing at all. Good. Let's head to part 2. And again, I'll only do 3 of the 4. If you feel like you're good to go, then we'll give you work time and call it good. So what changes here is we're going to have to employ property 3. So we're going to start with log base 5. Of 9x minus 2 log base 5 of 4 equals 0. Seeing it? It's okay if you don't. Anyone seeing it? There's an intruder. Someone has crashed our party. It's not the 0, it's the 2. That 2, bad. We cannot employ property 1 or 2 in reverse. We can't condense until we've successfully removed any annoying clingers in the front. And in this case, this 2 right here was brought here by having come from where he used to be. So I am going to show an extra step this time just for the benefit of anyone who might need this. What this problem really then says is log base 5 of 9x minus log base 5 of 16. That's because in reverse, property 3 says, well, hey, if I can bring an exponent down in front of a log, there's absolutely nothing stopping me from moving it right back up. And this allows me to condense. Again, the condensing doesn't happen if you don't do that. It always moves back to its home, which is going to be right here where this little red box is going to be. Because if we did property 3, you understand, Sam, that we would have dropped it from up there down into the front, right? You with me? You sure? Okay. At this point, it's just like the last examples we did. So would this condense? How would this condense? What would it say? 9x over 16. Yes. Clean up that 4 squared. No sense in leaving it laying around. Okay. And then from here, we're going to employ the water cycle diagram. I'm going to scroll just that much. I hope that's okay. Is everybody okay if I do that? All right. This to the this equals this. This to the this equals this. Over and over and over again. Just picture those little blue arrows. Whoop, the water cycling. Whoop. What is 5 to the power of 0? It is 1. So we have 1 equals 9x over 16. Remember that anything, can add a little side note if you need us, anything raised to the power of 0 will always equal 1. And then from here, it's just business as usual. Multiply both sides by 16, and you get 16 equals 9x. Divide both sides by 9, and you get x equals 16 ninths. Pretty ho-hum once you get past the early steps. Okay. How far? That far? Yeah. Sure. I'll write the next one, and then I'll give you guys a second to copy that, and then I'll scroll up again. So the next example is going to be log based. Oh, I'm good. Everybody else good? Yeah, no. Log base 5 of 3x plus 3. Log base 5 of 2 equals 3. It's like anything in math. 15 minutes ago, you would have had no way to do this. And it's just, math is, it's acquisition of a set of skills, right? And you've now acquired a set of skills. You understand now that to solve this equation, there's a certain prescribed set of steps that we have to follow. What's step 1? Get rid of that 3 that is not where we want him to be. Were we doing an expansion, then we'd say, you're right where you should be. You're right in front of the log where you belong. You're expanded. But now, in order to use the properties in reverse, we need to condense. And part of that is taking this 3 and zipping him back up to his old home up there. And I feel like I can probably, I don't want to. Never mind. I'm going to write the next step. I'm not even going to skip it. We're going to write log base 5 of 3x plus log base 5 of what? 8 is great, as my wife would always say. Yes, 8 is great. And then from here, what's the condensed version of the log going to be on the left?
Log base 5 x over 8.
I put a hint on the board in the form of a little yellow circle. You want to try again?
Log base 5 3x plus.
Listen to the wise whispering voice over here to the north.
Yes.
Yes.
No.
You're fine. What is 3x times 8? All right, we really should just skip right to that. There's absolutely no benefit of writing 3x times 8. We understand that we're going to multiply them, and that is what it is, but we might as well just put 24x. The less we have to write, the better. This is perfectly communicative. No math person reading this work would wonder what you did. Plenty of information, plenty of work to help you be successful. And then from here, it's time for the diagram, the water cycle. So what am I going to write here first? 125. That's a terrible 5. I'm just going to try again. Do gooder. There you go. 125 equals. And then we're going to divide both sides by 24. And again, I'm feeling like 125 is probably not divisible by 24. I think can you get on board with that? So I'm going to just claim then my answer. Don't have to love it, but get comfortable with it. It's just a fraction, 125 over 24. Do you guys have any questions about this? Do you feel like you need more examples? I had 8. I don't think we need them. So you good? I had the Delta Math program to upload or to assign itself, and I think it probably assigned itself 5, 6, 7 minutes ago. So I'm going to stop this, end this.